Hello, Phil Thomas, New Era Systems. Today I am looking at an Actox 20 watt extended C-Band BUC. Extended C-Band means that the bottom end of the range is 5.85, top end is 6.725 gigahertz, so that's extended C-Band. The nice thing about this BUC is that it works directly off AC, so you don't have to worry about getting 24 or 48 volts out of a modem. It also has an M&C connector, which we don't have, but it's very seldom that we need M&C on these little BUCs. It's a WR137 flange, two very corroded fan cover plates. Fortunately, they are easy to get, easy to change, and so when we finish with this, it will look somewhat better than it does now. Let's see if there's anything else significant on this BUC. Type N connector, that's where the 10 megahertz and the L-band will come in from the modem. Now, talking of the modem, this is what we're going to use today. Sitting on top of the modem, there is a combination cross-guide coupler and dummy load. This dummy load is good up to about 200 watts, but as we're only going to be testing 20 watts today, it will barely get warm. Now I'm going to connect everything up so we can begin the test. Okay, we're set up and ready to go. If you look at the BUC, you'll notice that there's a red light on there. The red light normally indicates that there is no 10 meg reference. So let's just go look at the modem and see if the 10 meg reference is turned on. Okay, so from this panel I'm going to go to ODU. ODU can control either the LNB or the BUC. In this case, the BUC, and we're going to look at the 10 meg reference, and it is off. So I'll change that to on. The warning light on the Actox 20 watt BUC has turned off, indicating that it's getting a good 10 meg reference. Also at the same time, the power. Also at the same time, the fans have just kicked in. Fans on this BUC are temperature sensitive. So now let's go back to the modem again. This time I'm going to look at the local oscillator frequency. Typically a C-band LO frequency is 4900. Yep, sure enough, it's 4900, so we're good there. The important thing about the local oscillator frequency is that it allows me to see the final RF frequency when I set the L-band on this modem. So let's go ahead and set the L-band. Go to transmit, frequency 950, that's right at the bottom of the range, and that corresponds to 5850 on the C-band range. So this is the beginning of the C-band test. Now I'm going to set the power on the modem. I'm going to set it way down, as you would normally do when you are commissioning these things or testing them in the first case. Manual. Neg 40 is as low as it will go, so we're going to leave it at neg 40. Check the on-off, and it's off at the moment. Okay, so I'm going to go ahead and turn the power on. And immediately we get a good strong signal on the spectrum analyzer. If we look closer at the frequency of the analyzer, it's 5850. So that's what we expect. I'm going to change frequencies now. I'm going to take it up to 1500. And don't forget, I'm talking about 1500 on the L-band range. And as you can see, that corresponds to 6400 in the C-band range. So I'm going to enable this, and you notice immediately that the signal has dropped off the spectrum analyzer. It's only dropped off because the spectrum analyzer isn't set to look at 6400. It's still transmitting okay. I'm going to change the setting on the spectrum analyzer now. Okay, there's the change on the spectrum analyzer. I've got a confession to make. I ran out of battery on my main camera yesterday, so 24 hours later, I'm just resuming the test. Now, as far as I can remember, I just changed the frequency to 1500 megahertz on the L band, and had to change the frequency on the spectrum analyzer to 6400, which of course is the matching C-Band frequency from L band to C-Band. And as you can see on the spectrum analyzer, it's fine. It's right in the middle of the range, so the frequency is accurate. And now what I'm going to do, I'm going to look at the power meter. I connected the power meter to the other port on the cross-guide coupler, and I set the power meter to compensate for the attenuation factor on the cross-guide coupler, and currently it's showing 35, nearly 36 dB, which is around 5 watts. So I'm going to go to the modem, and I'm going to increase the power on the modem. Now don't forget, this is a 20 watt buck, and so we should be able to get it up to 20 watt without a problem. I left it set yesterday at the lowest level possible, neg 40. So I'm going to take this down a little. Well, when I say take it down, what I really mean is I'm going to decrease the attenuation. What I really mean is I'm going to decrease the attenuation. In other words, increase the power. So it's neg 40 now, we're going to increase to 39, and watching the power meter at the same time, we can see an increase, 37. Now, what I'm looking for in terms of dBm, 20 watts should be around about 42, 43 dBm. So we're at 36 at the moment, 37, right? So I'm going to go back to power, manual, increase again, 1, 2, so I'm going to come down to neg 36, enter, we're at 39, we're at 41, we're getting close to 20 watts. 42 now. We're 44 watts shown on the power meter, and this is taken from the flange, which is the most accurate place to show it. And 44 watts is, we're heading up towards 44 dBm is heading up towards 30 watts. So I haven't taken it step by step to see where saturation begins. That's a long process, a boring process on a video, but I've just shown now that it will happily run up to 30 watts. And in general, this seems to be a very good buck. So I'm going to disconnect everything now before I run out of battery on the cameras again, and wrap it up for today. Thanks for watching.